So we have Unit 6, Objective 6, Polar Graphing. Last class you got to do the discovery version using Desmos. But this class, we're going to actually have it more formal. So we're going to say that we started off with petals. And so those equations are going to be R equals A sine B theta, and R equals A cosine B theta. A is the length of a petal. B is the number of petals. Anybody notice anything about, is the number in the equation always the number of petals?
No.
Evens are what?
Twice.
Double. So then we have to write that down, that if we have B is odd, then we have B petals. If B is even, we'll have 2B petals.
Wait, what's the last part?
When B is even, you're going to have 2B petals. The placement of the petals if we have cosine, the first petal is on the x-axis, as long as A is positive, that means you're going to the right. For sine, say that we're going to begin at the initial ray and the first petal is at 90 degrees divided by B. Doesn't matter if it's sine or cosine. Your petals are evenly spaced. That's a little crooked. So that's 360 degrees. What should I divide by? That would be true if B was always the number of petals. Did you say C? Well, that would be true if 2B was always the number of petals. There you go. Divide by the number of petals. But I did want to make sure we thought about that one for a second, because that is what people do wrong right there. They want to always divide by B. B is not always the number of petals. So you got to make sure you pay attention to how many petals you are. If it's even, you got to multiply that by 2. If it's odd, then you use that number. So we'll do some with actual graph paper, but I'm going to go ahead and just put that as a sketch right here. Example 1. If r equals 4 sine 3 theta, then I need petal number 1 is going to be at 90 degrees. So if I have 3 in front, that's B, in front of the theta. It's odd. Do I have 3 petals or do I have 6 petals? 3. So I'm going to divide by 3. So petal number 1 is at 30 degrees. And then the spacing is going to be the 360 divided by 3, which is 120. So I'm drawing a plus sign. It's not an XY axis. I just don't want to draw all the circles. But there's circles, right? And how far out am I supposed to go? 4. So I'm going to go ahead and mark this as 4. But I am going to go ahead and do this. This is the weird part. This part's not weird. This part's the weird part. When I'm over here, I'm still at positive 4. I'm talking about a radius of a circle here. These numbers all mean the radius of the circle. So even though we're going left and down, it's still a positive number. And anytime I go to make a petal, then I'm going to go out to the 4, because that's what A is. My first petal is going to start at 30 degrees, so I'm just going to take an approximation. We're going to do that a little better with graph paper, a little bit. And then I'm going to try to label this around. This is going to be important even on graph paper. I'm going to want you to say I'm going around 120 degrees, because that's what my spacing is. I'll put a dot. And then my next dot again is 120. Going to be down here. You can write the 120 for all of them, but as long as you just put the 120 spacing for one of them, that'll be fine. And then we're going to make these round at the dot. Don't make them pointed. So I'm going to make it kind of rounded and then go in towards the center. It's probably fatter than that in real graph, but I'm just trying to get the round. You don't want them to overlap. They should be even, which this looks terrible. That guy's dumb looking.
Wait, on the left,
Uh-huh.
what is that supposed to be at?
Where is that?
Yeah.
Well, it's 120 away from this one, so let's go label this actually. I like that question. So this is at 4, 30 degrees. I should have put that point there. So if I go 120, tell me where I would be over here. 4, 150. And if I go another 120, then I have what? 270. And another 120. I'm at 30 in a coterminal. So you just keep going back and forth.